In-depth analysis of the Hipparcos and Tycho catalogues. Overview of the Hipparcos and Tycho catalogues. The Hipparcos and Tycho catalogues are two of the most important datasets in astrometry, the branch of astronomy that deals with the positions, motions, and distances of celestial objects. These catalogues are the result of the European Space Agency's Hipparcos mission, which was the first space-based mission dedicated to precision astrometry. Hipparcos Catalogue, 1997. Named after the ancient Greek astronomer Hipparchus, this catalogue contains precise astrometric data for over 118,000 stars. It includes measurements of star positions, parallaxes, which help determine distances, and proper motions, how stars move across the sky. The Hipparcos data was crucial in refining our understanding of the distance scale in the universe. Tycho Catalogue, 1997. The Tycho Catalogue was generated using data from the Tycho experiment, part of the Hipparcos mission. It contains data for more than 1 million stars, though with less precision compared to the Hipparcos Catalogue. The Tycho-2 Catalogue, an updated version, was released in 2000, combining the Hipparcos mission data with ground-based observations to provide improved positions, proper motions, and photometric data for over 2.5 million stars. Scientific impact and applications. Refinement of stellar distances. The parallaxes measured by Hipparcos allowed for the most accurate distances to be determined for nearby stars. This has been critical in refining the cosmic distance ladder, which is essential for understanding the scale of the universe. Improved proper motion data. Proper motion data helps us understand the movement of stars across the sky. This is important for studies of the kinematics of stellar populations, the structure and dynamics of our galaxy, and for predicting future positions of stars. Calibration of the cosmic distance scale. The Hipparcos Catalogue provided the data needed to calibrate the luminosities of Cepheid variable stars and R Lyrae stars, which are key standard candles for measuring cosmic distances. Astrophysics and stellar evolution. The precise positions and motions of stars have been used to refine models of stellar evolution and the distribution of different types of stars within the Milky Way. Exoplanet discovery. The accurate astrometry from Hipparcos and Tycho has been used to confirm the existence of exoplanets through the detection of tiny wobbles in the position of stars, which can indicate the gravitational influence of orbiting planets. Fun and adventurous ways to use the Hipparcos and Tycho catalogues. Create a virtual star map. Using programming languages like Python and libraries such as Matplotlib or Plotly, you can create a dynamic interactive star map based on data from the Hipparcos and Tycho catalogues. You could allow users to zoom in and out, select stars, and display information like distance, magnitude, and motion. Simulate stellar motion over time. Develop a simulation that shows how the positions of stars will change over thousands or millions of years. This could be an engaging way to visualize proper motion and the dynamics of star clusters or the Milky Way. Build an exoplanet hunting tool. Create a tool that allows users to search for potential exoplanets by analyzing the astrometric data for subtle wobbles in a star's motion. You could incorporate machine learning techniques to help identify likely candidates. Augmented reality star chart. Using AR development platforms, you could create an app that overlays real-time data from the Hipparcos and Tycho catalogues onto the night sky. Users could point their devices at a star and get detailed information, including its motion, distance, and historical data. Astrometry-based navigation game. Design a space exploration game where players navigate through the galaxy using real star positions and motions from the catalogues. This could be educational, teaching players about the structure of the galaxy and the relative positions of stars. Create educational tools. Develop interactive educational tools or apps that use the Hipparcos and Tycho data to teach concepts in astronomy, such as parallax, stellar evolution, or the movement of stars in the galaxy. Stellar evolution storytelling. Using the data, you could create a storytelling project where users can follow the life story of a star from its birth to its eventual fate, incorporating real data to show how its position, brightness, and motion change over time. Data art. Use the catalog data to create visually stunning pieces of digital art. You could map out star positions, magnitudes, and motions to create abstract visualizations that represent the movement and structure of our galaxy. Predict future star configurations. Write a program that predicts how the night sky will look in the future by projecting the proper motions of stars from the catalogs. This could be an exciting way to explore how the constellations will change over millennia. Cross-reference with other astronomical data. Develop tools to cross-reference Hipparcos and Tycho data with other astronomical datasets, such as those from the Gaia mission or various exoplanet surveys. This could help in identifying new patterns or correlations in stellar data. Conclusion. The Hipparcos and Tycho catalogues have been pivotal in transforming our understanding of the cosmos. With advancements in technology and programming, there are many innovative ways to utilize these datasets for both scientific and creative endeavors. Whether you're interested in educational projects, simulations, or artistic interpretations, these catalogs offer a wealth of opportunities to explore and visualize the stars.